All right. So again, the quiz that we are scheduled to have, I will just postpone it here until we get everyone in class because of the weather. Questions on homework? Sorry? Did you say you had a question? Go ahead. Which one is it? Number 55. Okay, we have 4s squared minus 36t squared. All right, so for this problem, we got to start going through our steps here. We look at it, we say that we have two terms, right? We have a binomial, right, two terms binomial, and do we have a GCF? What is the GCF? 4. So we can factor a 4 out. We have s squared minus what? 9t squared. Now, okay, so look at the inside of the parentheses. You have two terms, right? You have subtraction between them. So it could be maybe a difference of squares or a difference of cubes. But because you have squares on them and 9 is a perfect square, you start thinking difference of squares. So the question becomes, can you take this? I'll do this on the side. Can you rewrite that as something squared minus something squared? This will become your A and this will become your B if you can do it. So S right here, okay, so S, of course S squared is S squared. And then what do you square to get 9? 3, and then what do you, yep, 3t. So that means that your A is S and your B is 3t. So using that formula, it should be A plus B, A minus B. Is that all right? So S plus 3t, S minus 3t. That's it. Any other questions on the homework? Yes. Well, I don't know. What do you mean doesn't matter how you write the answer? Mm-hmm. Yes. Plus A squared. Wait, A squared. Wait, he said you could write it A squared. That's not correct. Well, let's look at the problem, okay? 27 plus A cubed, right? Now I'm going to try and walk through this with you so you can help me understand what the tutor explained to you. So maybe I'm missing something in the way he said it or something. Did the tutor switch the order? Like put the A cubed in front of the 27? Is that what he did? Okay, so can we do that? Can you switch that? Well, it's addition, isn't it? And so addition is commutative, which means you can reverse the order. As long as you keep the sign. See, the 27 here, it's implied that it's positive. And back here, it's still positive when you switch it. Here, the A cubed is implied that it's positive. And when you put it here, it's still implied it's positive. The only thing that would be tricky is if there were some negatives in there. So you can reverse that. That's fine. You don't have to do this problem, but you can. Well, let's continue because What you said doesn't match up with what it should have been. So hold on. There's no GCF here, right? You have two terms, and there's addition between them, right? So you start thinking it's either sum of squares or sum of cubes. Remember, sum of squares, it's prime. But this, unfortunately, is not that because you have a cubed, and then we recognize 27 as being 3 cubed, right? So this looks like a sum of cubes. Can I rewrite it as something cubed plus something cubed? So what do I cube to get a cubed? A. What do I cube to get 27? 3. So my a in the problem is a, and my b in the problem is 3, right? I'm going back to that formula from last class. A cubed plus b cubed equals a plus b, a squared minus ab plus b squared, right? So if I do that, first thing I put is a plus b, which would be what? A plus 3. Then in parentheses, a squared, which for us is, well, a squared, minus ab. It's 3 times a, right? So minus 3a. And then plus b squared, so plus 3 squared, which is 9. Is that what the tutor said you could have? Exactly, that's when? Okay. That would be okay. Yes. I thought when you said that, you had said -9. Or I thought you had said -9 when you told me. Okay. If that's the way it's written, yes, that is correct. Now, had I done this problem, I would not have flipped the order. I would have just said, can I rewrite that? And you would have got 3 and a, like this, instead, right? 27 is 3 cubed, a cubed is a cubed. And now my a is actually 3 and my b is actually a. But I still use the formula. If I do that, I get a plus b, so that's 3 plus a. A squared, which would be 3 squared, so 9, minus a times b, which is 3 times a, then plus a squared, which is exactly the same as this, right? A plus 3 is the same as 3 plus a. Then I have an a squared, positive, right? A squared. I have a minus 3a, minus 3a. I have a positive 9, positive 9. So these are exactly the same, just different order. Where? No squared on this, because what is this? This 9 is actually a squared, right? For us, a is 3. 3 squared is 9. So I'm already squaring it, and that's why it's a 9. If I wanted to leave the squared here, I would have to put a 3 squared. I did hear you say that when you said the answer. You said 9 squared. Yeah, 9 squared would not be correct. It would have to be 3 squared or 9, preferably 9. Okay, yeah, we're still waiting on people to show up because of weather. So I'm going to start today's lesson on factoring. We're going to move on to our next topic. And what you're going to notice is that when you get this, I have a handout for you. I don't have handouts very often, but that's how important this is. It's going to say 6.2, factoring trinomials. It's actually not 6.2. It's, hold on. It's actually 6.4, but don't worry about it because I didn't make this thing up. This is what happened was the math department decided that we wanted everyone to teach this particular topic the same way so that when you go to the next class, you will be subjected to you'll have the same expectation. Everyone's learning it the same way. There's some uniformity. You go to the tutoring lab, they're going to show it to you the same way, that sort of thing. Because there's like a dozen different ways to teach this topic, And when you have a dozen different ways and you go to get help, the tutor tells you one way, but the tutor next to him tells you another way, and then I tell you a different way. It just makes for a real confusing situation. So this will be officially the first semester that I ever teach it this way. So we'll see how this goes. But the sections, I'm not sure why they don't match up with the book. I'll have to look into that, but it's not important. What's important is what's in this handout. So you're going to be my guinea pig class here, okay? I don't know how this is going to go. There's two there. Sorry. Well, let's see how this goes. Let's see how this goes. Because I do have a way, but this way that I'm going to show you, if you can get it down, it's the fastest way. It's the quickest way to do these problems, but it's also, it requires some thinking, which is a good thing because you want to think, right? It's not as robotic as just like do this, then this, then this. You know, this requires us to reflect a little bit on some ideas. So just kind of read through that for a second. I'm going to bring this document up so that we can see it up on the board. Wow, it's actually, the website's actually working today. Oh. You know how you have a Canvas page for the class? This is a Canvas page for our math faculty. So only math faculty can get in here. It has all the stuff that I guess we share with each other. So what we're looking at right now is this factoring notes right here. And let me bring up this program. I haven't used it in a little while, but it's a pretty cool program. It allows me to write on top of my screen. There we go. All right. View, full screen, Control L. That's no good. Can y'all see that all right? Okay. You've got it in front of you. We've got it up on the board. Let's read through this. We are seriously going to take our time through this. This is, I mean, what we've done up to this point, GCF, grouping, that's all great, okay? But at the end of the day, when it comes to factoring a trinomial is the most challenging, and it's the most useful, and it's the thing that will hang you up in college algebra, all right? So we've got to get this down. Trinomials. Now, trinomial, we've already talked about. A trinomial is 3 terms, right? But we're looking at a specific type of trinomial right now. We'll look at another trinomial either later today or in the next class. The one we're looking at right now is a trinomial of the form x squared plus bx plus c. Now, x squared is our variable, and there's a 1 in front of that. Imagine there's a 1 sitting in front of that x squared, all right? Next class, I will have a handout out. I will hand you something where we deal with if there's a number other than 1 in front of that. Today, it's a special case where this is a 1. Then we have some number in front of x, so that could be like x squared plus 2x plus, I don't know, 3. Got it? How do we factor things like that? Well, let's go back to, well, this is an example of one, right? X squared plus 8x plus 15. That's an example of a trinomial. Looks exactly like this. What's b here? 8. What's c? 15. Be careful. b is 8, right? The b is the number in front of x. So b is just 8, not the x included, all right? So that looks like that up here. How do we factor something like this? So we start with this. We want to get back to here, don't we? We want to go from here to over there. Well, to do it, it helps to look at the process it takes to get to this. So when we have this, we FOIL it, don't we? We do, I told you I don't like FOIL, but for this example, that's the way they want to show it. So x times x, right, gives us the x squared. That's the f in the FOIL. And then you do what? O would be the outer ones. So x times 3 gives you this 3x. Then you do the inner ones. 5 times x gives you the 5x. And then the last one, 5 times 5 gives you 15, right? See, the thing is, how do we come up with the 8x? Where does this 8x come from? It comes from these two being put together, right? The 3x and the 5x. What's difficult for us, do you see that? No? Yeah. What's difficult for us is for us to go from this back to the left side, how do we know it was a 5 and a 3, right? If I just stand right here and I look at this 8x, how do I know it came from 5 plus 3? How else could you get 8x? What two things could you add together to get 8x? 4x and 4x? 6x and 2x? 1x and 7x? How about 10x and negative 2x? Right? There's so many different ways you can get 8x. Right? Oh man, am I already? Thank you for, that's weird. Oh, that's right. My class yesterday, I didn't plug in. Oh, I do. Who else? Here, I think there's 3 there. All right. So do we see that the 8x comes from 5x and 3x? Please just don't text. That's if you understand this, you got this. I'd rather you just leave and go do whatever than to sit in class and text. I appreciate that. Okay. So 5x and 3x add up to be 8x, right? But where does the 5 and 3 come from? Well, does anyone kind of see where the 5 and 3 might come from? Well, 15 also, right? See, 15 was here. 5 times 3 is 15, isn't it? So maybe there's a connection. Maybe that 15 tells us that where that 8 comes from. And it turns out that's what it is. So this is going to be kind of an inspection thing. Let me see. Do we have any extra copies? Okay. So that's what this note says. Note that from the multiplication of the two binomials above, the middle term 8x is the final product resulted from the sum of the outer products in the FOIL process. I can't stand when people try and explain math. Okay, all they're saying here is that notice that 8x comes from the O and the I, right? The outer and the inner parts of FOIL added together, right? All right, and more importantly, that the coefficients of these inner and outer terms are the factors of the last term. So the coefficients, the 3 and the 5, right, when you multiply them, give you the 15. Okay? These facts will be important as we work backwards to factor this. So remember, this is the first time I've been through this, all right? So let's... If they're, what's that? This middle term will always come from these two being added together, but then the coefficients, the 3 and the 5, should always give you that. Okay. Here are the steps. It looks pretty ominous, doesn't it? Before you begin, make sure that you have a trinomial in the form x squared plus bx plus c. If not, write it in this form. If possible, factor out a GCF from the trinomial. Well, we've already talked about GCF, right? We always want to pull a GCF out. This is a critical step, though, right here. You might want to highlight this or underline it or something. This includes a negative if the leading term is negative. So if you had a negative x squared to start the problem, you would want to factor a negative out. I'll show you an example. We're going to do some examples. There's one in here that has that. You'll see. You always want to pull a negative out before you start continue with this process. Huh? Because the negative will mess up you trying to figure out what these numbers are. Okay? And if you pull that out, then you won't have to worry about it. All right, so next one. Make a side note of whether you will be adding or subtracting to get the middle term. Okay, so you remember how I said that we had that 8x up there? And I said, how many different ways could we get 8x? We could do 3x and 5x, or 4x and 4x, or we could have done 10x minus 2x. We're either going to be adding two things together to get 8x, or we'll be subtracting two things. And this step that I'm talking about here is how we determine what it is, okay? So make a side note of whether you'll be adding or subtracting to get the middle term. If the sign of the constant term, C, is positive, you will be adding. If the sign is negative, you'll be subtracting. What are they talking about? What's C here in the problem? 15. So here, C was what? Positive. That means I'm going to be adding, which you can tell that's where it came from. I added two things together, right? If this was a negative term, if this was negative 15, then you would actually be subtracting instead of adding. That means, what that would tell you is that this 8x came from two things being subtracted instead of added together. Just let's go through this. I know it's difficult to look at steps first without doing a problem, but that's what we're going to do. All right, now, write out all the factors of the constant term C. Write them in order starting with 1 times C and in order down to the two factors that are closest to each other. In this step, disregard the sign of C when writing C. So look at this example they have here. What if the C was a 24? So remember, C is that last number by itself. What if it was 24? We'd write a little table. We'd write 1 times 24, right? 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. 5 times anything? No? And then the next one is what? 6 times 4, but I already have that. Okay? So what you want to do, what they mean by write them down in order to the two factors that are closest to each other. So you get, these are real far apart, right? 1 and 24, 2 and 12 are closer, 3 and 8 are even closer, 4 and 6 are really close to each other. That's the closest you can get. That's when you stop. Does that make sense? Okay, that's the fourth step of this process. Now, we are looking for we're looking to break whatever number we have down into all its possible factors of two numbers. Okay, so let me, well,Ll write on this. Look, check this out. The problem that we had just a second ago, it was, what was it, x squared plus 8x plus 15, right? The step that we're talking about, I would look at 15, right? I would create a table for 15 that would look like this. All the things that multiply to be 15, starting with 1. 1 times 15. What else multiplies to be 15? Go to 2 now. Does 2 times anything give you 15? How about 3 times anything? 3 and 5? Anything else? 4 doesn't? 5? Well, we already have 5, don't we? So we're done. Does that make sense? That's what we would do. Okay, so you write down all the different factors. Now we look for the two factors from your list, right? Look for two factors that will add or subtract depending on what we had said in step 3. Were we going to add or subtract for this problem? We were going to add, right? For the one with 15, we were going to add. Look for the two factors list that will add or subtract to give you the coefficient in the middle term. So we would be looking in here to try and get that middle term to be created. I don't think this is a good example. Let me move back to this. What were we trying to get as our middle term here? 8x, right? And 8. So, and we said we want to add here. So which of these add up to be 8? Well, 1 and 15 add up to be 16. but 3 and 5 add up to be 8. So we would identify those two as our numbers. All right? Once we've done that, determine what the signs of the two factors found in step 5 must be to give you the exact value. We'll just have to work through an example for you to see what I'm talking about. Then all you do is place whatever numbers you got, place them right here, and we're done. So in our problem, we had 3 and 5, we put them here, and then we check it. Okay, that's the idea. That's the idea. Let's work through it. I think, I can give you the steps all day long, but until we do them, you won't see how this works out. So let's try and do this one. See, do you see the bottom left? You see this? All right. So I'm telling you, I'm not saying it's a bad idea. This is just another way of doing it. That's fine with me. We all agree to it. So that's the way we're going to do it. Okay, x squared plus 13x plus 36. X squared plus 13x plus 36. Okay, let's start looking at this thing. Let's try and take it step by step. You've got the steps in front of you, right? First thing, does this look like x squared plus bx plus c? Yes? Is there a GCF? Not in all three terms, right? No GCF? Is there a negative in front of the x squared? No. So there's nothing to factor out. So I've kind of gotten already past the first few steps, right? What step am I on? So step 1 I've got, right? I wrote it down. Factor GCF, right? I don't have that. So I've done step 1 and step 2. Step 3 is to make a side note of whether I'll be adding or subtracting. So I'm going to put here that step 1 is done, step 2 is done, step 3, I'm going to make a side note. Am I going to add or subtract in this problem? Well, am I going to be adding or subtracting the two numbers I find? Adding, because this is a plus, right? Because that's a plus, I will be adding. Okay, fourth step. Write all the factors of the constant term. This is where we make our table, okay? We're going to make that table now. And what are we going to make the table on in this problem? 36. And I don't care what the sign was. If that was a negative 36, as you'll see in another example, I would not put negative 36. I'm always going to look at just the number positive, the positive number there. So 36 136, right? That will always be there, right? 1 times 30, whatever the number was. Does 2 go into 36? How many times? What is it? 18 times? 18 times? So 2 and 18. You can use your calculator here if you need to, okay? Does 3 go into 36? 12 times? Does 4 go into 36? 9 times? Does 5? Does 6? 6 and 6. And we can stop now because these are as close together as you're ever going to get, right? 7 wouldn't work. 8 wouldn't work. 9 we already have. 9 times 4. So as soon as they don't have to be the same number, but they'll get to a point where they're real close together, and then after that, you start repeating things in your table. Does that make sense? Okay, now what are we going to do with this? That was step 4, right? Step 5 is to look for two factors from the list that in step 4 that will add, right? For us, it will add up to be the middle term. So what's our middle term? 13x, right? We need to look for numbers in this list that when you add them together, you get 13. What is it? 4 and 9, right? By the way, these numbers are grouped together, right? It's 1 and 36, 2 and 18. You can't say 2 and 12. You can't go from one row to the next. It's straight across, all right? Does that make sense? Okay, so 4 and 9. So step 5 in this process is to write down, to figure out what the two numbers are, 4 and 9. Right? What's step 6? Determine what the signs are of the two factors found in step 5. They must give you the exact value and the sign of B. Well, in this problem, we don't have to worry about it because these are both positive, right? And we are going to add them together. What's positive 4 added to positive 9? It's positive 13. That gives you exactly what we needed. So there's no work to be done for 6, other than to say, you know, for 6, they're both positive, right? 4 and 9. Step 7 is to write out two sets of parentheses, XX, and then whatever these two numbers are, right? Put them here and here. Now, I think because, again, this is my first time through this, remember on step 6 we said we had to figure out what the signs were? Let me do this. Let me put plus 4, plus 9, just to stress to you that these are both positive. And then on this step, what we're going to do is just take those and put them here and here. So it'll be x plus 4x plus 9. And that's our answer. Now, step 8 is to check it. How could we check it? FOIL it. Okay, so what's x plus 4 times x plus 9? X squared plus 9x plus 4x plus 36, which is x squared plus 13x plus 36. Does that match what we had to start? Yes. Now, I'll be honest. This process it's called guess and check. Okay, guess and check. You're kind of guessing at numbers here that might work, and then you're getting things that look like they work, and you check it. This method is you're supposed to get so comfortable with this method that what happens is that you stop writing anything down, really, and you just start doing it all kind of mentally. You just look at the problem, you say, okay, I'm looking at this problem. I need to create 36, right? And I need to create a 13, but those two numbers need to multiply to be 36. So, okay, how many different ways can I get 36? Well, 1 in 36, 2 in 36, and you're adding them in your head as you're thinking through. Oh, wait a minute, 4, 9, 4, 9. Wait, 4, 9 is 13. Oh, that's it. And you try and do that all mentally. But it takes you doing a lot of these problems to get to that point. Okay, let's look at the next example. X squared minus 3x minus 40. I may as well use that other program I have just to show you it's kind of cool. I can draw on top of my screen. See, that's different than that other one because that other one's just like a program. Who's ever used OneNote before? OneNote, yeah. See, this is a program that writes on top of your screen. It's pretty neat. Okay, what's the first step? Okay, first step is to write it in that form, right? It is in that form. It looks like x squared plus bx plus c. Help me out here, everyone. What's b in our problem? -3. What is c in our problem? -40. Okay, be careful with that. I just want to make sure you're paying attention to the signs a little bit here. But does it look like this? Yes? Okay, so that step's done. Step 2, factor out a GCF, and if there's a -1 in front of x squared, factor it out, which I don't have again, right? So no GCF, no negative, so I'm good. Step 3, what does step 3 say? Am I going to be adding or subtracting, right? Isn't that what it says? Yeah. Were there any extra copies of that? No? No. I have a handout. Okay. Well, it's a handout that I gave everyone, so you can, if you want. Well, or you can sit next to someone too if you want. You go with it? All right. Okay, so step 3 says to do what? Are we adding or subtracting? And what tells us if we're adding or subtracting? The minus in front of the 40, right? It's a negative sign. That negative sign means I'm going to be subtracting. Okay? So I'm going to be subtracting since we have negative 40. Here's a way to think about this, if you're wondering why it's going to be this way. The only way to get a negative number, remember this is our last term, our 40? Didn't we say the two numbers that create this have to multiply to be this? Like we had the 3 and the 5 earlier, multiplied to be 15. If we had a negative 15 in the previous problem, we would have known that one of those numbers would have had to have been negative, which means that it's going to be subtraction, right? You have two things, one will be positive, one will be negative. Well, that's just where it comes from, okay? So we know that we're going to be subtracting these numbers. What's the next step? Find the factors. So I'm going to write down a table. This table is going to be for what number? 40. Not negative 40, but 40. So let me try and put my table here. 40. I'm going to start with 1. 1 and 40. 2 and 20. Just 3 going to 40. Okay, 4. 4 and 10. 5 and 8. 6 doesn't work. 7 doesn't work. 8 we already have. The fifth step is to determine two numbers on that table that subtract, right? That subtract to give you what? That subtract to give you negative, sorry, oh, there it goes. Negative 3, right? See how I highlighted that negative 3 up there? We want to try and figure out from this table, which of those numbers could I subtract to get a negative 3? 1 and 40. So I want you to do it this way. What's 1 take away 40? Negative 39. What's 40 take away 1? 39. What's 2 take away 20? Negative 18. What's 20 take away 2? Positive 18. What's 4 take away 10? Negative 6. What's 10 take away 4? Positive 6. See what I'm doing? What's 5 take away 8? Negative 3. And that's what we wanted, right? And 8 take away 5 would be positive 3. So we want a negative 3, don't we? So we want to use these numbers, right? The 5 and the 3, the 5 and the 8 are what we want to. The 5 and, forget it, I should just go back to the other program. The 5 and the 8 are what we want to use, right? But we want to, on step 6, determine which signs they're going to be. So let me, oh shit. That program's gone, never mind. We're not using that anymore. So we have our table, right? We had 5 and 8 down there. We are on step 5. So now we're on 5. The two numbers we're going to use are 5 and 8, right? Step 6 is to determine the signs on those, right? So we wanted which one of those to be negative? The 8, right? So we want the 5 to be positive and the 8 to be negative. Do you see how that 6th step works? We know the 5 and the 8 are the numbers that'll get us a 3, but we want it to be a negative 3, so we have to make one of them positive and the other one negative. And then step 7, you put right into two sets of parentheses, x, x, and then you just put whatever those two numbers are using their signs. Plus 5, then minus 8. And you can check it yourself. FOIL it, it'll work. Right? What do y'all think? Yeah. Yeah. If you Well, what do you not like about this way? Too much steps? Too many steps? Well, I know we're just starting though. You know what I'm saying? I'm trying to get us. No, this is good feedback because you know. I understand that. I got a couple of messages today about people being late, so yep, that's fine. Okay, well let's see here. Let's look at this one. Let's see if we can do this one mentally. I'll tell you how it works mentally. Right? I need two numbers that multiply to be what? 60. Multiply to be 60, but add up to be negative 19. So maybe you make a quick little thing on the side, a squared. What was it? A squared, what was in the middle? Minus 19a plus 60. So maybe all you need is the table at this point. Maybe just 1 and 60, right? 2 and 30, 3 and 10. 3, thank you. 2 and 30, 3 and 10. What am I doing? 4 and 15. Hold on. 4 and 15 do go together to give me a 19, right? However, what do I know about this right here? It's positive, which means I'm going to be adding these two things together, right? But the only way to get a negative 19 from 4 and 15 is to make them what? Both negative, right? Negative 4 and negative 15. If I say what's negative 4 plus negative 15, that's negative 19. So that'll work. And they multiply, negative 4 times negative 15 multiply to give me, multiply to be positive 60. That's the way, I mean, but I just feel like I'm already, it's too soon to throw you to the wolves like that, because if you walked into this class having seen factoring trinomials before, you've done it, then you probably have some sort of guess and check mentally already. And I'm not here to reinvent the wheel. Stick with what you're comfortable with. But if you don't have anything and you need a method, I'm giving you one. All right? And if you go to the tutoring lab, that's what they're going to give you too. It's what they're going to go through. They should, hopefully. So I'm going to go, I'm going to do this by the steps, okay? And we'll talk about the way that I would normally show this in a class in a minute, all right? So the first step, it's in that correct order. Second step, there's no GCF, there's no negative sign. Third step, I'm going to be doing what? Adding two numbers together. Fourth step, I make my table. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7, no, 8, no, 9, no, 10. It's already on my list, right? So that's it. So what I'm trying to do, my goal for step 5, is to figure out if there's a way that I can get a negative 19 from these numbers. And we already said that 4 and 15 would be the closest I could get, right? But I would have to make them both negative. So step 5 is just to identify what the numbers are that you're going to use. Step 6 is to get their signs correct. So I need them to both be negative so I can get a negative 19. So negative 4, negative 9. Step 7 is to do your parentheses. X what? Minus 4, x minus 9. Hold on. Why? 15. Sorry, 15. Everyone's freaking out. I know. Sorry. This was 4 and 15, -4, -15, -4, -15. Oh, it's A. Good. Thank you. I'm glad you grabbed that. It's too early, man. I'm glad you pointed out A, because that would be a mistake. Probably not. Because it's more to me about the method right now than it is about, okay, you missed it. I just missed the variable too. It's okay. Let's work through the rest of what's on here. All right, look at that one. 9x minus 12 plus 3x. 9x minus 12 plus 3x squared, is that it? All right. So now we want to try and get our heads out of just what we were doing today and just kind of take a step back again, talk about our general factoring strategy, which is always looking, saying, okay, I've got 3 terms, right? So I'm going to use that method that I've been taught that one day with that big old handout, right? 3 terms. GCF is always what you start with, right? Do we have a GCF? What is it? 3. So pull that 3 out. You'll be left with 3x minus 4 plus x squared. Now, the thing that's inside here, is it of the form of what we're doing today? What's in here? It's 3 terms, right? Trinomial. It has to look like x squared plus bx plus c. Well, we need to get it in that order, don't we? So we need to put the x squared up front, the x term in the middle, and then the number by itself. So I'm going to rearrange things. Do y'all agree with that? Now let's see. Can you do this one quickly? What 2 numbers multiply to be -4, but add up to be +3? 1 and 4. Okay, but one of them has to be negative. 1 is negative. 4 is positive. So if you look at that, would 1 and -4 work? +1 and -4. These 2 numbers multiply to be -4, but add up to be positive. Positive. God, I need to go like kick myself in the hallway or something. Right? And now you could go straight to the answer. Do you want me to go through the 8 steps on that one, or you're okay with that? Okay, look at this one. -n squared plus 12n minus 20. Thank you. I have the memory of a fly or something right now. Minus 20. Three terms, right? Is it in the right order, like x squared, then, well, not x, but the order was like variable squared and then variable and then number? Okay, what's the one thing I do need to take care of here? The negative in front of the n squared. So I'm going to factor a -1 out. That'll leave me with what? N squared minus 12n plus 20. What you've done is you've removed the negative off of every term, or you've changed the sign of every term, but you got to have that -1 out front. All right, well, let's see how y'all do with this then. if I'm trying to get a negative 20, right, negative, then when I multiply two numbers together, I need to have one of them be negative, right? What numbers multiply to be negative 20 but add up to be... Hmm? I'll tell you why. I don't, because I'm really having a tough time here right now. Okay? Sometimes you just have these moments, right? I'm looking at this, but it's sitting right here. This is what we need to be looking at, right? Jesus. Need to find my Zen again or something. I'm gonna scratch that out so I don't even look at it again. Okay, in this parentheses is exactly what I want to look at. I'm trying to get a positive 20, right? And a negative 12. So 10 and 2 multiply to be 20. And if they're both negative, they multiply to be 20 still, and they add up to be negative 12. Negative 2 and negative 10. This is starting to look very similar to the way that I teach it now. All right. Of course, you could check this, right? Multiply it through. Let me give you one. Yes. How come, is it because you took the negative out? Is that why the order changed from the positive? Yes. 12 to the negative 12? Yes. Because by factoring negative 1 out, remember, if I multiply this negative back through, I would get negative n squared, which I have. I would have positive 12n, which is up here. I would have negative 20, which is here. But see, this method does not work if you have that negative out front. Let me show you what would have happened had we not done that. Man, just dropping the ball big time today. Okay, so let's say we would not have done that, right? Then you would have said what? Negative 20 and positive 12. So what would that, would that have even worked? Would negative 10 and positive 2 have worked? No. Would 10 and negative 2 have worked? No. Right? What would have worked? Well, maybe I do need a table. 20. What are the things for 20? 1 and 20, 2 and 10, 3, 4 and 5, and that's it, right? Is there any way to get a 12 out of this? 10 and 2, right? But the problem is there's no way to get the negative. The negative 20 won't, you can't get negative 20 from these unless one of them is negative. But then if one of them is negative, when you add them together, you don't get 12, you get either negative 8 or positive 8. So you would look at that and think it's not factorable, when in fact it is. And that's just because that negative out there throws everything off. You pull that out and everything will work. Okay, let's look at what else do they have on this page here for us. How about that one? X squared plus 2x plus 24. X squared plus 2x plus 24. Would you like to see the way that I do it? I mean, it's nothing crazy different than what we've been doing. I just organize it a little bit, that's all. And you may have been taught this method. What you do is you make like a little x, not a little x, a big X. Okay, make a big X. I put mult up here for multiply and add down here for add. So what we need, think about what we need. We need a number that multiplies to be what? Two numbers that when we put them together, we get what? Positive 24. But when we add them together, right, when we put them together, we need the middle number, which is what? positive 2. So I put that down here. And so all this does is organizes your idea. Now you just have to come up with these two numbers that when you multiply them, they give you this, and when you add, they give you this. So can you think of two numbers that multiply to be 24 and add up to be 2? So maybe we still need the table. See, this is where, even if you're good at this, if you can't figure out the numbers, you need some way of organizing the idea. Can anybody tell me what the numbers are? 4 and 6? If I put 6 and 4 here, what's wrong with that? They multiply to be 24, right? But they add up to be 10, not 2. So those won't work. What if I make it 6 and negative 4? That multiplies to be negative 24, though. What if I do negative 6, positive 4? That multiplies to be negative 24. Negative, negative, now they add up to be negative 10. Right? At the end of the day, this one's not factorable. If you can't come up with the numbers that make it happen, it's not well, I should say. If the numbers don't exist that make it happen, then it's not factorable. If you can't find the numbers, that might just be on you. Like they may be there, but you just can't figure them out. So, but this one, there is nothing we can do. If we take 24 and we try and make a table out of it, 1 and 24, right? 2 and 12, 3 and 8, 4 and 6, 5, 6, we're done, right? How many different ways can we get these together to give us a 2? This not even close, right? 1 and 24 aren't even close. 2 and 12 aren't even close. 3 and 8, they're within 5 of each other, right? 4 and 6 are the only two numbers that would possibly work. But because I have to have a positive 24 when I multiply them, they either both have to be positive or both have to be negative, right? No, you can't do anything. This is prime time. Prime time here. I'll give you a good example. How about this? This is one of my favorite examples. Okay? So how are you getting that? So you've obviously got a method and you're comfortable and you're on your calculator, you're just checking numbers. And I would encourage you, if you're good with it, go with it. Why did you look at 2 and 3? Why didn't you look at 6 and 1? Yeah. So this is an example that I like because it can trip people up, even people who are pretty good with it. If you put this little X over here, I'm looking for a number that two numbers that multiply to be what here? 6, so positive 6, but add up to be negative 5. A lot of what I see is people will jump the gun here and they'll put 6, negative 1. Because 6 minus 1 is 5. But 6 times negative 1 is negative 6, not positive 6. So those don't work. So what were they? Negative 2 and negative 3 are the numbers that work. So again, the only way I think you could really be sure of that is to make a table. 1 and 6, 2 and 3, that's all you've got, right? 1 and 6, can you put 1 and 6 together to get a 5? Yeah, you can, but the problem you're going to run into is trying to get the signs to match up. 2 and 3, can you get 5 from that? Yes, you just have to get the signs to match up. So this is why they call it kind of a guess and check method. You kind of guess at it a little bit. If you try 1 and 6, check it, it's not going to work. Does that make sense to y'all? So what is the answer here? X minus 2, x minus 3. Okay, what about this? Almost looks like the exact same problem, doesn't it? But I need -6 and -5. What two numbers multiply to be -6 but add up to be -5? 1 and -6, right? Because 1 take away 6 is -5, but 1 times -6 is -6. So from here, I just do x plus 1, x minus 6. How do y'all feel about this? And then all of a sudden they throw something like that at you. Looks worse than it is. It says you try it. So that means you, not me. So you try that, okay? Go through all the steps and see if you can factor that completely. Does everyone have it written down? Got the problem written down? Because I'm going to switch screens here. Hey, what do y'all think about that one that I gave you? Were you able to get it? Okay. I was going to work through it real quick. Okay, who's going to read that out to me? 2a cubed b squared 20a squared plus what? 50 ab squared. Okay, that's it. So first thing, 3 terms GCF. Okay. 2b, not a cubed. Yeah. Okay, like that. All right. So GCF first, right? And what about a number? What number can we pull out? 2. How many A's? How many B's? So B squared comes out, huh? And we're left with what then? A squared minus 10A plus 25. Inside there we have a trinomial, right? Looks just like what we were doing today. I have the number 25, and I have the number -10. What two numbers multiply to be 25, add up to be -10? 5 and 5, but both negative, right? Here's something you can try and keep in mind. If this number up here is positive, what can you tell me about these two numbers? They're both the same sign, whatever they are, right? They're either both positive or both negative. So if this number up here is positive, these are the same signs. What if this number is negative? Then they had to both be negative in this problem, right? Like if this is positive and this is negative, then these both have to be negative. If this is positive and this is positive, then these both had to be positive. You see, you can start to kind of like deduce these things, but it takes a little time to get comfortable with it. So -5, -5, that work? Y'all good with that? So it becomes 2ab squared and then breaks down to be a minus 5, a minus 5. That would become, that's a great question. You could do a minus 5 squared. What you cannot do is a squared minus b squared. That is no. Or a squared minus 5 squared is what I meant to put. Oh, we're going to do a quiz. I didn't forget. I didn't forget. So let's take a quick vote, okay? My intention was to give problems just on difference of cubes, sum of cubes. How many of you would like me to put one of these on the quiz? Yeah? Okay, I'll put one of these on the quiz too. So I'm going to give you two problems, all right? So please, let's see what you can do with nothing but your brain right now and a piece of paper. On your piece of paper, put your name, put today's date, 3/27/14, and make sure you put on there you're in my 9:30 a.m. class. That way I can figure out who you are. And do these two problems. For both of them, factor completely. 27x cubed minus 8. I will put the formulas up here. Number 2, I want you to factor x squared plus x minus 12. When you're done, just turn it in and you can go. Just do your own work, please, okay? Those are the formulas from last class.